Okay, guys, let's see. Sine and cosine ratios. Now, yesterday we talked about the tangent ratio, guys. And remember, that's the TOA part of SOHCAHTOA. Okay? Now you need to remember the whole thing. SOHCAHTOA. Okay? Do you need me to write them in different colors? So, that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And TOA is tangent. TOA is tangent is equal to opposite over adjacent. That you have to have memorized. Okay? So I'm done even talking about that. The sine ratio of an acute angle. I don't know why I keep writing angel. Is there something wrong with me? Maybe I'm thinking about angels. Of an acute angle. And look, I did it again. You know what? I cut and pasted. That's why I made the same mistake. That's the danger with cut and paste. You cut and paste mistakes and you repeat. Okay? The sine ratio of an acute angle in a right triangle is equal to the length of the leg opposite the angle divided by the length of the hypotenuse. So, the sine of A, right? The sine is equal to the opposite over the hypotenuse. Opposite side divided by the hypotenuse. Okay, good enough. Now, the cosine is equal to the adjacent over the hypotenuse. So the cosine of A is equal to B over C, right? The adjacent over the hypotenuse, huh? How about that? Okay. Now, remember, the nice thing about this is that when we find out those values, we can plug them into the calculator and it'll spit out the angle measure for us. We don't have to use a protractor to measure it. Okay? We can, but we don't have to. All right? So let's look at example number 1 here. Does everybody have those ratios, that side? We understand that different ratios have different names. Opposite over hypotenuse. What ratio is that, Nikki?
It's sin A.
Okay, let's get this straight, and that's okay. Sin, S-I-N, that is an abbreviation. We need to make sure we pronounce it correctly because we're going to look weird or even evil. Okay? So, S-I-N stands for sine. Okay? Sine. C-O-S stands for cosine. So, opposite, as you said, over hypotenuse is the sine. Okay? What does opposite over adjacent? What is that ratio? Opposite over adjacent. Trigo? No. Oh, you thought I would go with the new one today. But I'm actually testing you on the old one. What is opposite over adjacent, Trigo? No, not at all. You're going to have to look at your little cheat sheet that you wrote down. Opposite over adjacent is equal to what, Ty? The tangent. That's what we worked on all last night. Okay? What's the adjacent over the hypotenuse, Fritz?
The adjacent over the hypotenuse is the...
Take your time. You didn't write it down? Oh, that's okay. I typed it for you. What is the adjacent over the hypotenuse?
Sin.
No, it's not sin.
Oh,
Please.
Cos
It's not cos. See, that's why I took some time just a moment ago saying it, so I wouldn't have to say it now.
Cosine A.
Cosine, okay, is equal to the adjacent over the hypotenuse. Okay? Now, Ethan, in this first example, it says that for triangle JKL, all right, find the sine and cosine of L. Okay, well, first off, you're going to find the cosine of L for me. But before you do that, cosine is always equal to what side over what side, Ethan?
Adjacent over hypotenuse.
It's the adjacent over the hypotenuse. And guys, you should write that down so that hopefully you'll begin to remember it. Okay? Thank you, Fritz, for taking the half a second to write that down. I appreciate it. Okay? Now, Ethan, what is the length of the adjacent side to L?
15.
15, right? 8 would be the opposite side, wouldn't it?
Yeah.
Okay, so it's not 8. We want to get rid of that. It's 15 over the hypotenuse. What's the length of the hypotenuse? 17. Great. And we're going to leave that as a fraction in reduced form for now. Okay? Fine. All right. Now, Liam, I want you to find the sine of L for me. But before you do that, the sine is equal to what side over what side?
The sine is equal to opposite.